Hello guys, welcome back, and today's video I will continue the chapter water, and today we will complete the chapter completely. So we have done few portions of this chapter. Yes, now we will continue the chapter. So today we will learn about crystallization and water crystallization, and after that we learn hydrated and anhydrous substances or crystals, and after that we learn about efflorescent, deliquescence and hygroscopic substance, and at last we will learn about drying and dehydrating agents. So this is the topic that we are going to discuss today. So let's start the chapter. So I will give the schedule for my next 6 videos to you. Okay, in 21st we will look conditional statement in Java part 2. In 23rd we will take next chapter of chemistry named atomic structure and chemical bonding, and we will end this chapter on 28. On 25th we will end conditional statement in Java. In 30th I will take the next chapter called periodic table and of Java called iterative constructs in Java on 2nd December. So if you want to keep, you can keep. Not necessary, since I will upload videos anyway. So we'll start about crystals, crystallization and water crystallization. Crystals, we are heard crystals, we have heard many types. So what is this crystals? When a saturated solution, the hot saturated solution, we have learned what is saturated solution, what is unsaturated solution. Remember, I have taught you in the first video. If you haven't seen that part, then please go and visit that part. Okay, if you haven't seen it yet. So saturated solution means which cannot dissolve more of the solute at given temperature. So when a hot saturated solution, you have to cool that hot saturated solution. Then you will get some excess solid, and that excess solid is in the form of a particles having definite geometrical shape, and it is arranged symmetrically, and they are also homogeneous. Such solids are known as crystals. Okay, when you use a hot saturated solution, you cool it. Okay, and there will be some excess solid after cooling. So these substances form are known as crystals, and it is in how can you determine whether it is crystal by its property, like it have its own geometric shape, like cube. It can be cube, it can be rhombic. Rhombic means rhombus, it can be hexagonal, and so on. Also, it is homogeneous in nature and it's arranged symmetrically. By these characters, you can determine that these are crystals. Got it? And crystals also have its own plane surfaces, sharp edges. Can you see these sharp edges here? This diagram, sharp edges, and a definite angle to one another. Okay. You have to learn what is crystal, its properties of crystal. Don't need to study its shape. I have just given the shape. Okay. Next, we will learn about crystallization. The process by sorry I forgot right by this. Process by which crystals are separated from hot saturated solution of a substance on gentle cooling is known as crystallization. You get these crystals, yes? You get these crystals, you separate these. After getting crystal, you have to separate these from hot saturated solution. This process of separating crystals from hot saturated solution on again gentle cool or cooling gently, and this process is known as crystallization. Okay, next, the fixed number of water molecules. The fixed number of water molecules which enter a loose chemical combination with the substance during crystallization process for a hot saturated solution is called water crystallization. What is water crystallization? So fixed number of water molecules. There will be fixed number of water molecules. Let me take uh, as example. Let me take one comma. Okay, so calcium sulfate CaSO4 dot 2H2. How many water molecule? 2H2O, meaning two water molecules. So these water molecules enter in a loose chemical combination with the substance, and it is and when the substance is When it happens only when substances crystallize from hot saturated solution. So of this phenomena where fixed number of water molecule it enter into what loose chemical combination during crystallization of substance from hot saturated solution is called water crystallization. Okay, you have to only learn what is crystal, properties of crystal, what is crystallization, what is water crystallization, along with some examples. Now let us look at hydrated and anhydrous. Hydrated means what? Hydrated means it contains fixed number of water molecule, while anhydrous does not contain fixed number of water molecule. Hydrated substance contain fixed number of water molecule and enters in loose chemical combination. For example, CuSO4 dot 5H2O, or it is known as blue vitriol. An anhydrous crystal does not contain fixed number of water molecule in loose chemical combination with the substance. For example, potassium nitrate. Is there any water content? No. But copper sulfate have water content. How many? 5 water molecules. But KNO3 doesn't have any water molecule. Learn this equation. CuSO4 dot 5H2 gives CuSO4 plus 5H2. Okay, this is CuSO4 dot 5H2. CuSO4. This is copper sulfate vitriol. Can you see it is blue in color? This vitriol is blue in color. It contains fixed number of water molecules. We cannot see it because it is very minute and present at the edges, like here. Present at edges. We cannot see this minute things. Okay. Next, we learn about some hydrated crystals, some of its chemical name and its formula. First is dihydrate calcium sulfate. Di means what? Di means 2. So it means CSO4 dot 2H2O. Its chemical name is gypsum. Next is tetra. Tetra means what? 4. So tetrahydrate calcium hydride means CaNO3 twice dot 4H2O. Its chemical name is lime saltpeter. And next is penta. Penta means 5. So copper sulfate CuSO4 dot 5H2 blue vitriol. It is known as blue vitriol. Next is hepta. Hepta means 7. Heptahydrate magnesium sulfate, that is MgSO4 dot 7H2. It is known as Epsom salt. Next is heptahydrate, that is hepta again means 7. Iron 3 sulfate FeSO4 iron 2 sulfate, sorry, FeSO4 dot 7H2 and decahydrate. It is known as green vitriol. Okay. Next is decahydrate, which deca itself means 10. It is known as Glauber salt in chemically and its formula is Na2SO4 dot 10H2. Study this table very well. Next is some of the anhydrous crystals. Okay, you all need to study any one or two names. Okay, but you have to know its formula very well. You have to know formula very well. Study one or two anhydrous crystal. Potassium sulfate K2SO4, ammonium sulfate NH4 twice SO4, potassium chloride KCl, lead chloride PbCl2, potassium nitrate KNO3, sodium nitrate NaNO3. That's all. So you have to learn what is hydrated crystal, what is anhydrous crystal, this table, and 2-3 anhydrous crystals. Next is efflorescence and deliquescence. Listen, like there are crystalline hydrated salts. Now, when you keep these substances on atmosphere, it completely loses its moisture. Okay, when you keep or when you expose crystalline hydrated salt on atmosphere, it loses its moisture, sometimes partially, sometimes completely, and it changes in the form of a powder known as amorphous powder or amorphous state. So these substances are also efflorescent and the process is known as efflorescence. Example, Na2CO3 dot 10H2 or washing soda. Then you have copper sulfate. Then you have global salt. These one example on any one or any two example. Okay. Next is deliquescence. What is deliquescence? You have okay. Now some water soluble salt. When you keep or when you expose water soluble salt to atmosphere, it absorbs moisture. Okay, and it changes in the form of a liquid state. And this form substance is known as deliquescent, and this phenomena is known as deliquescence. Example: FeCl3, iron 3 chloride. Okay, this is example of this. So, what is efflorescence? Yeah, when you expose a crystalline hydrated salt on atmosphere, it loses its moisture, sometimes partly or sometimes completely, and changes in the form of amorphous state of powder. And this form substance is known as efflorescent, and the process is known as efflorescence. For example, washing soda. What is deliquescence? Water soluble salt, when you expose to atmosphere, it absorbs moisture and changes in the form of a liquid state. And this product is called deliquescent, and this process is known as what? Deliquescence. Example: iron chloride, calcium chloride, salt. Not any one or two example from each. Okay, this is washing soda and this is iron chloride. Okay, I just give it diagrams, that's all. So, you know, there is a statement, okay, this is very important. Efflorescence and deliquescence are caused by difference between vapor pressure of the crystals and the atmospheric humidity. Give reason. Look, look at the reason. Efflorescence, when does this efflorescence happen? When the vapor pressure, when the vapor pressure of the hydrated salt exceeds vapor pressure of atmospheric humidity. That is when you expose these, when you expose to air, what happens? It loses its moisture. Its reason is the vapor pressure of this salt exceeds vapor pressure of the atmosphere. Due to this, efflorescence happens. Got it? What is efflorescence? When you keep these substances on air, when you keep this what substance, crystalline hydrated salt on air, it loses its moisture and changes into amorphous powder. It is because the vapor pressure of these salt hide crystals exceed vapor pressure of the atmosphere. Due to this, efflorescence happens. What about deliquescence? When you expose water soluble salt to atmosphere, it absorbs moisture and due to that it changes to liquid state. So what is the reason? Because deliquescence occur when vapor pressure is very low as compared to vapor pressure of atmospheric pressure. Hence, efflorescence and deliquescence. These things are different things. That is, efflorescence occur when vapor pressure exceeds vapor pressure of hydrated crystal exceeds vapor pressure of atmospheric humidity, while deliquescence occur when vapor pressure of these water soluble salt is very low as compared to vapor pressure of humidity. That is, first one exceed, second one very low. Okay, got the difference? Due to this, efflorescence and deliquescence are caused by difference between vapor pressure of crystal and atmospheric humidity. That's the whole reason. Next, common salt turns moist on exposure to air. What is the reason? Look, common salt is not deliquescent. Okay, it is not deliquescent, but it contains some small amount of calcium chloride and magnesium chloride. These common salt, it is not deliquescent. What do you mean by deliquescent? When you expose to air, it absorbs moisture. Consider if common salt was exposed to air, it changed liquid state. Does salt change liquid state? No, salt doesn't change liquid state. Yes, due to that, hence it is not deliquescent, but you can say it is efflorescent. is somewhat efflorescent. Okay, like it is in the form of a powder, common salt. It is the form of a powder, but it contains small impurities of calcium chloride and magnesium chloride, and that is deliquescent. Look, common salt, common salt is what? Not deliquescent. It is not deliquescent. But the impurities of calcium chloride and magnesium chloride, it is what? What do you call? Deliquescent. Okay. Common salt is not deliquescent, but the small impurity of calcium chloride and magnesium chloride is deliquescent. Due to this absorption of moisture, it turns what? Humid, so moist and sticky and wet. Okay, especially during humid conditions. Got it? This you have to learn it. Next, we will learn about hygroscopic substances. Hygroscopic substances also absorb moisture from air, but it doesn't. It may sometimes it is amorphous solid and sometimes it is amorphous liquid. Okay, but it doesn't changes to, but does not change its state of matter. Okay, so that substances are known as hygroscopic substances. For example, silica gel. You know, when you buy a bag in shop, a small packet is there. It is called silica gel for absorption of moisture. Those silica gel is hygroscopic substances. Example of solid hygroscopic substances: quicklime, that is calcium chloride, sorry, calcium oxide, silica gel, and liquid hygroscopic substances: concentrated sulfuric acid. You have to learn solid hygroscopic substances, one or two, then liquid hygroscopic substance, which is the only liquid. There is only one liquid hygroscopic substance, concentrated sulfuric acid. There is no other liquid hygroscopic substance other than concentrated sulfuric acid. You have to also learn what is hygroscopic substances. Next, we are learning about drying and dehydrating agent. Most of the hygroscopic substances are known as drying agent. For example, concentrated sulfuric acid. It is also hygroscopic substance. It is also a drying agent. It is also called dehydrating agent. What is dehydrating agent? Dehydrating agents are those substances which remove chemically combined water or element of water from compound. The reason is behind due to the strong affinity of water. Okay, removal of chemically combined water or elements of water from compound due to strong affinity of water. Those substances are called dehydrating agents. And what about drying agent? Those are the substances which absorb or remove moisture from other substances. Okay. Example: fused calcium chloride. It is a drying agent or desiccating agent. Okay. Drying agent and desiccate. When you insert this calcium chloride in desiccator, it is known as desiccating agent. Desiccator is a device for drying agent. Okay. This desiccator, it is a device. When you keep this device, it's a device. Now, when you keep this fused calcium chloride in desiccator, it is known as desiccating agent. Fused calcium chloride is also a drying agent. What is drying agent? Substance which can readily absorb or remove moisture from other substances. Okay. Example: concentrated sulfuric acid is hygroscopic. It is also a drying agent. It is also a dehydrating agent. This is concentrated sulfuric acid. Okay. So that's all about this chapter. Hope this chapter is all clear to you guys. We have completed this chapter in 2 short. If you haven't seen the part 1, please visit part 1. I will continue this chapter. Take this chapter of chemistry called atomic structure and chemical bonding after the next video. Next video is that part 2 of the chapter called conditional statement in Java. After that, okay. Anyway, please like the video, share with your friends, subscribe syllabus tracker so that you will get more videos like this. Okay, I will see you guys in the next one. Stay safe, stay healthy. Goodbye.